So the question, right, is asking for this, to fill in these blanks. Yeah. So to find that, right, I've got the answer. So the answer, right, is just to differentiate the term on top. So for this one, right, you just have to differentiate this to get this half, negative half sine half x. Yeah. So the second term is the same lah. So you just differentiate the one on top, get this. So for this side, right, the function of pi, you just have to sub, for this, right, you sub pi into this. So the answer you should get 0. Then for this is the same thing, you just have to sub pi into this. So when you press your calculator in radian mode, you should get this. Yeah, so it's the same for all this. Yeah. Then next, after you have gotten the answer, right, the Taylor series for the top 3 terms, you should get this. You see? Yeah. So this is the formula. Once I sub the value in, so f pi, right, you should get 0, so you just sub. So f naught, as in this, f prime x, you should get negative 0.5, which is over here. So you just sub it in. So after you sub everything in, right, to the term, your answer should be this, after you simplify the form on top. Yeah. So moving on, right, they want us to do this, the steps. So I've got the graph, like the blue one is the one that they want. So they ask, do the two graphs look exactly the same? My answer is no, because they look the same only when x is less than, as in less or as in greater or equal to 0, and less than or equal to 5.97, which is around 6. Okay, next question, what can you do to make the two graphs look more similar? We should continue further with the Taylor series steps, which is like to increase further than just the 3 terms instead. So it's the same thing for this. You just have to differentiate for this term, right? You just have to differentiate this, which is you should get the term over here. So it's the same steps. So you differentiate the one on top. For this, you differentiate the one that's on top. Yeah. Then this is the same thing. You just have to sub pi into the term over here. You should get 0. And then this you sub into, as in the pi you sub into this. You should get this answer. Yeah. So now they ask for the Taylor series with the added terms. So your Taylor series should look something like this. The 5th and 7th, because the 4th, right, and the 6th term, they are 0. So when you sub it in, it's 0. So might as well don't put it in. Yeah. So now they ask us to put it into the graph. So now the graph, right, should look like this. The orange color is the one that they want, because it's like the line tree. So you should have something like this. Yeah. So now they ask, what conclusion, right, can you make about approximation of the function using Taylor's series? So my answer is, right, the more terms you obtain for Taylor series, the better the solution. Yeah. So the last question is, the 3 graphs seem to be exactly intersecting at x equals to pi. Why do you think that this is the case? So looking back, right, they have mentioned, right, that find the Taylor series for the function cosine half x about x equals to pi. So they mentioned like x is equals to pi. So that's why the graph should be intercepting at x. Yeah, that's all.